Hi everyone, I'm Delcy Rollheiser, the Math 30-1 exam manager.
And I'm Jenny Kim, the Math 30-2 exam manager.
Welcome to our session on writing effective machine-scored questions in mathematics. We are going to go through a great deal of material in the next hour and a half. So as Wanda mentioned, if you have questions on anything you see in the presentation or questions dealing with assessment in general, please utilize the Q&A button at the bottom of your screen. If we have time, we'll do our best to answer those questions at the end of the presentation. If not, Jenny or I will contact you afterwards to answer your question. When writing items, we need to consider many different factors, many of which are listed on your screen right now. A well-balanced test blueprint will have an appropriate weighting of each of these elements, but it's important to note that each of these need to be considered when creating an item for assessment. In order to address these factors, you need to know where to find all of the related information. First, we need to start with the program of studies. Every item that appears on an assessment must assess at least one specific learner outcome in the course's respective program of studies. The program of studies for each mathematics course contains general outcomes, the overarching statements about the content students are expected to learn, and the specific outcomes, the more detailed statements about the exact knowledge, skills, and understandings that students are required to attain by the end of instruction. It is very important that every question is directly related to a specific learner outcome. Here is an example of one page from the Math 30-2 program of studies. In the topic of probability, the general outcome is develop critical thinking skills related to uncertainty. You can see there are 6 specific outcomes that describe the knowledge, skills, and understandings that are related to that general outcome. Because the specific outcomes are formatted as students will statements, they provide teachers with information about what students should be able to do in order to meet the program expectations. Note that the outcomes are describing what students will do, not what teachers will do. The intent is for students to be actively involved in the development of their knowledge and skills. Most of the time, teachers work and assess the specific outcomes as they provide more detailed information about what students need to be able to demonstrate. This is the program of studies. Notice that there are letters in the square brackets at the end of each specific outcome. These are the symbols representing the mathematical processes. Knowing which math processes are listed for each outcome should inform both instructional activities as well as assessment items. Each specific outcome lists the math processes that teachers would expect students to employ when working with that outcome. Your assessment items should align with these processes and target the same skills. For example, 14 of the 24 Math 30-1 specific outcomes do not list technology as a math process. So when assessing these outcomes, students should not be utilizing technology as a key part of their solution strategy. This is an example of a question that may not assess the outcome using the intended mathematical processes. This question is trying to assess relations and functions specific outcome 11 that asks students to factor polynomial expressions. The processes listed in this outcome are communication, connections, and mental mathematics and estimation. However, many students will determine their answer by graphing the given function and observing the x-intercepts on the graph. This is a problem, as the intent of the outcome is to determine the factors without technology. The students who use this strategy are not illustrating that they understand the mathematics associated with factoring polynomials. To fix this problem, we can either change the question to remove the ability to use technology, or we can change the format of the item to target a non-graphical approach. This question may be better suited for a written response format.
Another factor that needs to be considered when writing items is the student-based performance standard of an item. So how do we determine if an item is at the acceptable standard level or the standard of excellence level? So in assessment, the 2 student-based performance levels have been defined. A student who achieves an acceptable standard will receive a final grade between 50% and 79%. As you read through the definition, one thing to highlight is that these students can apply their knowledge to familiar problem contexts consistently. A student who achieves a standard of excellence will receive a final grade above 80% and have the ability to apply their knowledge and conceptual understanding to a broad range of familiar and unfamiliar problem contexts. These definitions were used to create descriptions of the expected achievement at each standard level for every specific outcome. It's important to note that these assessment standards do not always relate to the difficulty of a particular question, but it describes the type of thinking or understanding that is involved in completing the task. There are documents outlining the assessment standards for every outcome in each high school math course. The Math 30-1 and Math 30-2 standards documents are posted on our website in the Writing Diploma Exams section on the Diploma Exams page. Documents outlining the assessment standards for the non-diploma courses are posted on our website in the Program Support section on the Mathematics Programs of Study page. The layout of these documents look different compared to the diploma course versions, but all the documents are available in both French and English. This is a layout in the non-diploma course documents. With each specific outcome, notes are included for teachers to use as guidelines in their classroom instruction and assessment practices. For each specific outcome, their corresponding achievement indicators are listed, along with specific examples from the approved resource to clarify the levels of the acceptable standard versus the standard of excellence. Here is an example from the Math 20-1 outcome with from the Math 20-1 Outcomes with Assessment Standards document. If we look at Achievement Indicator 2.4 for specific outcome 2, a student achieving at the acceptable standard level should be able to simplify radical expressions that involve only square roots, whereas a student achieving at the standard of excellence level should also be able to simplify radical expressions that involve radicals with indices greater than 2. This document should not be treated as a checklist for instruction. It is meant to help teachers define the achievement that should be attained at each level. As mentioned, the layout for the diploma exam course documents are different. The diploma exam branch, in consultation with the Program of Studies branch, created both of these documents, which have now been archived since 2018. For diploma courses, general notes that pertain to the entire topic are provided, as well as notes for each specific outcome. The notes are for teachers regarding the expectations relating to the assessment of the outcome. Similar to the non-diploma courses, the expectations for the acceptable standard and the standard of excellence are detailed in this document. But this time the expectations are listed in conjunction with the specific outcome and not the achievement indicators. Again, the assessment standards should not be used as a checklist. This document is designed to support the implementation of the program of studies and illustrate the intent of particular outcomes. You will also find a series of exemplars after the standards descriptors for each topic. The exemplars provided are neither prescriptive nor exhaustive. We blueprint our assessments based on balancing the specific outcomes, the assessment standards, and also the cognitive levels. This means that when creating items, you also need to consider the cognitive level. The cognitive levels in math refers to the different cognitive loads associated with questions or tasks in the program of studies. Throughout the course, you want all 3 levels to be present in the work you do with students, in their classwork and in their assessments. In each diploma exam, we look for 30% of the items to be procedural, 34% of the items to be conceptual, and 36% of the items to be problem solving. These definitions can be found in the information bulletins that are posted on our website. To illustrate the different cognitive levels, we have included a few examples and the analogy of tying shoes. Here's an example of a procedural question. We equate this to, can you tie your shoe? We have tied our shoes so many times in our lives that we don't even need to think about it. We can just do it, most likely using our muscle memory. In this example, students are required to convert an exponential equation to logarithmic form. This is a familiar and straightforward process that students recognize and can execute, thereby being procedural. Here we have an example of a conceptual question, and we equate this to, can you describe how to tie your shoe? Do you understand how it works? In other words, are you able to explain the process? Do you understand the mechanics of the process? Compared to the previous example, in this question, students need to interpret the given constraints on the parameter values to determine how it impacts the features in the graph of the polynomial function. This goes beyond the mere recall of facts or the application of a procedure. Students need to understand how each parameter value affects the key features of the function, and then they may choose to generate their own graph and use it to identify which statements are correct. Since students are using and applying their knowledge of polynomial functions to solve this question, this example illustrates the demands of a conceptual item. Lastly, we have an example of a problem-solving question, which we equate to, can you tie your shoe in a new way? Can you take the knowledge that you have and apply it in a new and unfamiliar situation? In this question, students must read the problem, identify a strategy, and apply their knowledge about set theory. Students would likely draw a Venn diagram and then notice that two regions are blank. They will need to interpret that last sentence in the context box, which says there are 3 more students taking English only than there are students taking biology only. And they'll need to interpret this in order to determine the values in the remaining 2 regions. Their strategy may be to reason it out, or they may choose to use the algebra. The higher cognitive level of problem-solving questions require students to solve unique and unfamiliar problems, which may require the use of appropriate language and correct math notation and conventions.
So now it is your turn. We're going to activate a polling feature in which we want you to read the item that's going to appear on your screen and determine if you think the item is a procedural question, a conceptual question, or a problem-solving question. Once you've answered the poll, you can also try to classify this item according to the topic, specific outcome, and the standard. So in this particular question, it is a Math 30-1 example. It is assessing relations and functions, specific outcome 6, and it happens to be at the standard of excellence. The cognitive level for this particular question is conceptual. The reason why this is conceptual is students need to know how the restriction on the domain applies to the inverse. So they have to understand what the graph looks like, what an inverse will look like, and then restrict the appropriate domain. Let's try one more. We have a Math 30-2 example. Again, try and determine what the cognitive level is for this particular question. And if you have some time, the topic, specific outcome, and the standard. So this time, our topic is probability. The specific outcome is 5. It is at the acceptable standard, and the classification is problem solving. The reason why this item is problem solving is because in this case, we are giving them the number of arrangements and asking them for the initial pieces. This is most likely a very unique situation and asks them to think very differently than working the other way around. To summarize, when creating effective items, you must consider the philosophy of the program, the item's curricular validity, consider the outcome you wish to assess, the intended mathematical processes associated with that outcome, and the standard and cognitive level of the item content. In addition, don't forget to ask yourself, does the item assess something worthwhile? Once you've considered all of the factors, you're ready to proceed with item creation. Let's start with tips for creating multiple choice items. There are two main types of questions, context-based and discrete. The parts of a context-based question are the context box, where key information and conditions are explained, the STEM, where the student determines what they need to do or find, and the alternatives, usually one correct response and 3 distractors. The STEM can be written as a full-stop question or in a complete the statement format. The parts of a discrete item are the same, except in this type of item, there is no context, which means that there is no context box. When creating a context-based item, ensure that you are as concise as possible and include only relevant information. In this example, there is unnecessary information in the context. The fix is to include only the information required to answer the question. Sometimes it is necessary to add to the context in order to add clarity to the question, but make sure that if you are adding information, it is purposeful. You don't want to increase the difficulty of the question through excess reading. The selection of source material for use in the construction of data-based and context-based questions is the initial and the most important step in the process. The information should be reliable, authentic, and relevant to students. Students should have to use the information in the source to answer the question. When creating the STEM of your item, be as focused as possible. Ideally, a student should be able to formulate an answer to a multiple choice question without looking at the alternatives. This STEM could refer to anything. The second STEM is much more focused. Additionally, try and phrase the STEM in positive form. However, sometimes a STEM must be written in the negative. For example, in Math 30-2, there is an outcome that is directed towards testing not, which is associated with the concept of complements in set theory. When used, highlight key or negative words that may impact how a student begins solving a problem or the answer they select. It is also important to correlate the directing word used with the intent of the item. For example, the word determine, according to our Mathematics Directing Words document, means that student work must be shown to receive full credit. If this word is used in a multiple choice or numerical response item, students might be confused as their work is typically not graded for these types of items. Consider using other words such as calculate, state, or identify instead.
Now we'll look at guidelines for writing the alternatives. So first of all, remove repetitive materials from alternatives and place in the STEM or reformat the item. Self-explanatory. Make sure that the alternatives are balanced. In other words, keep the alternatives similar in length, grammar, sentence structure, and content complexity. As well, keep the alternatives in logical or numerical order. So we refer to that as pyramiding. So pyramid accordingly. Often we go largest to smallest or smallest to largest, or in alphabetical order. Make sure that each alternative is based on a possible misconception. You want to make sure that all distractors are typical student errors. Keeping a record of the rationales is also helpful so that you know how each distractor was created. And if need be, you can revise them easily if you happen to change any values in the context or STEM of the question. Make sure that the distractors are curricular and avoid distractors that are beyond the program of studies. Students will not be drawn to a distractor if it contains content they've never seen before. And lastly, avoid all of the above or none of the above in your alternatives. So I'll just give you a minute to look over this example from Math 30-1. So there are two issues with this example. First of all, the STEM is unfocused. More needs to be given so that the student knows what is being asked. So just to clarify, when you read for the polynomial function described above, well, that can mean anything. So we need a more focused stem. And secondly, even though the distractors are parallel and plausible, the same phrases are being repeated each time. This can be fixed by changing the format to add clarity to the stem and reduce the repeated information. So with these changes, the question could look like this. Reformatting this item to a fill-in-the-blank stem and table format for the alternatives drastically reduces the repetitive reading and provides the student with a much more focused stem. Second example, give you a minute to look that over. So the issue with this question, the last word in the stem cues the correct response, or in this case, it would eliminate the two choices of A and B. So be sure that there is grammatical consistency between the stem and all the alternatives. So to fix this issue, rewrite the first two distractors so that all of the alternatives contain more than one color and keeping the distractors plausible. And our third example. So you're given the graph, ask for the amplitude of the graph. And in this case, you want to avoid distractors that cause a 3-1 split. So a 3-1 split occurs when one choice looks drastically different or involves an element that the other three alternatives do not. Such a split may cue the student to the correct answer or unfairly suggest a wrong answer. So in this example, 3 of the alternatives are 3-digit values and 1 is a 2-digit value, which happens to be the correct answer. So a possible fix for this problem is to find another plausible distractor that only has 2 digits. So in this case, changing that 120 to 80. And if it's too difficult to come up with a reasonable third distractor, it might be better to change that question to a numerical response format. You will also want to make sure that all of the alternatives are viable. Distractors should distract students away from the correct answer for mathematical reasons within the curriculum. In this Math 30-2 example, the term similar is not used in the course. So most should be able to eliminate C and D automatically. And if a student knows at the very least that probability can't be a value greater than 1, then they can eliminate B and D. So with some test wiseness and without doing any mathematics, students could get the correct answer of A. So this version of the item is better. All wording is directly related to the Math 30-2 course content, and all probabilities are less than 1. And our last tip for you is to try and avoid inadvertently linking questions together. Meaning, in other words, if the student is not successful on the first question in a set, they will automatically be unsuccessful on the following question, or one question cues or gives the answer to another question. So ensure that all the questions are as independent of one another as possible. This is true for all question formats, not just multiple choice items. In written response items, avoid having the answer from one part being needed to proceed to the next part. For example, in part A, if a student is asked to write the equation of a function related to a context, then in part B, have students determine the inverse of a different function and not the same function in part A. If there is a soft link between questions in written response, students who incorrectly answer the first part, but then uses that incorrect answer to correctly answer the second part, then the scoring rubric should reflect this and give those students credit for what was done correctly.
So let's take a look at some tips for creating effective numerical response items. The suggestions we just provided regarding the selection of appropriate context and writing stems also applies to numerical response items. However, we do have some specific tips for items that do not require alternatives. Be aware that a numerical response question is usually more difficult for students. This is a very important thing for you to consider when creating your item. Think about the number of steps required to get a solution and how long it will take for students to complete those steps. Also be aware of the cognitive level of thinking. When responses aren't provided for students, it generally amps up the question. Also consider the number of digits required in the answer. The number of digits should be indicated wherever appropriate. Because there is only one keyed answer for numerical response questions, it's very important to provide this information to students. It will provide clarity for them. You can do this in two ways. One, giving them instructions after the question, such as record both digits of your answer in the numerical response section on the answer sheet, or you can tell them directly in the STEM where you want the answer to be rounded to. So for example, we're asking the value of tan 35 to the nearest tenth. When creating a numerical response item, consider the best type of format for the question you wish to ask. There are many different formats that will target different skills and knowledge, which may be important if you are considering the different cognitive levels. So we have a listing of some examples of some different types of numerical response questions. Typically, we want to bring those forward to you so that you think about what format is the best. Here is an example of a calculation question. I'll give you a second to just give that a read. In this particular item, you will notice that we tell students which column to enter each digit of their response. A second example about sequencing. In this example, it is appropriate to tell students to enter all 4 digits of their response in the correct section on the answer sheet. This is an example of a matching question. This matching example also illustrates an item where there is more than one correct answer. If you are accepting more than one correct response, indicate this in the STEM. Our fourth example is expressing a process. If it is important for students to write the digits of the response in a particular order, you can indicate this by using the word respectively. Here's our last example. This item requires students to use a code for classifying. If you choose to write an item in this format, be sure to keep the code simple and easy to understand. We would like to finish off today's presentation with some general information from the differential assessment sector. Teachers are involved in every stage of the assessment process, creating items, validating field tests and diploma exams, and marking of student responses. If you are interested in participating in our working groups, please submit your name to your principal or your superintendent. These nominations are accepted all year long. If you are interested in participating in marking diploma exams, please watch for the call for nominations that occur every September and February. Teachers must go through the appropriate approval channels to be eligible to participate in both working groups and marking sessions. There are many opportunities to field test in both Semester 1 and in Semester 2. Field testing is an essential stage in the development of fair, valid, and reliable provincial exams. Field tests provide students and teachers with examples of the style and content of questions that may appear on provincial exams. Information about field testing can be found in the Field Testing Program Guide. This includes information on how to register, what deadlines you have to register by, and the types of field tests that we have available to you. Any questions that you have pertaining to the field test registration or administration can be emailed to fieldtest@gov.ab.ca. This presentation highlighted several important documents. Please look for these documents and others not mentioned in this presentation on our website. Our website also contains information on how to get involved in our working groups, marking sessions, and field testing.